This is for Year 12 methods. It's question number 7 out of 1.6 using the modulus function. A light will reflect from a surface. So, if we have, this is my surface, and I have my torch over here, it's shining a light towards the surface and it will reflect. It will reflect in the x-axis. That's just like having the modulus of a particular function, because instead of the light going through the surface continuing in the same path, it gets reflected in the x-axis and ends up having this happening, very much like what happens in a modulus function. And it says then talks about similarly a function's negative portion, this is the negative portion, will be reflected in the x-axis when the modulus is taken. Okay, so I've got a ray of light. It originates from 4, 8. That's where it originates. That's where the torch is, or that's where the spotlight is, or that's where the star is, whatever it is that's the source of light. It originates from 4, 8 and hits the surface at an angle of 71.6 degrees. Now, let's think about that. If it went like that, this would be my angle theta, measured away from the x-axis in a positive, which is anti-clockwise, but that's greater than 90 degrees. So my torch must be going in that direction so that it hits at an angle of 71.6. So my torch must be here, and my light's going in this direction, hitting, and that's 71.6 degrees. And then the light gets bounced back off in this direction. Find the angle of this ray of light. Okay, so I know this angle, therefore I can work out the gradient, because the gradient will equal the tan of 71.6 degrees. And if I bring up a calculator, and I can see that the tan of 71.6 is 3.006, so I'm going to round that off and make that a degree of a gradient of 3. Okay, so my gradient is equal to 3. And I know it goes through the point 4, 8. I can then work out by going y minus 8 equals 3x minus 4. Y equals 3x minus 12 plus 8. Y equals 3x minus 4. And that's going to be the equation of the light. Now, that's my ray of light. And that's going to have a particular x-intercept. That's the equation only for that component. I'd need to work out what my x-intercept was. So 0 equals 3x minus 4. 4/3 is going to equal to x. So it's positive when x is greater than 4/3. So my rule is going to be y equals 3x minus 4 when x is greater than or equal to 4/3. It's going to equal minus 3x plus 4 when x is less than 4/3. Because when x is less than 4/3, the equation would actually be down here. It gets reflected over the x-axis, therefore it gets multiplied by -1. -1 times 3x is -3x, -1 times -4 is +4. So that's the equation of this light ray before it's been reflected and after it's been reflected on the surface. And the other two rays originate from positive 2 units to the left and 2 units to the right of this original ray. Okay, so 2 units to the left gives me a light which originates from 2, 8, and another one that originates from 6, 8. Find the equations of these two rays assuming that they are projected at the same angle to the surface. Okay, I can use my transformations. If I move 2 units to the right, I replace x with x minus 2. So my new rule would be y equals 3. I'm going to replace x with x minus 2 minus 4. Y equals 3x minus 6 minus 4 minus 10. And the same deal is going to happen with having a modulus rule. And this one here, I've moved 2 units to the left, so I replace x with x plus 2, and it's going to be y equals 3x plus 2 minus 4, which is going to be 3x plus 6 minus 4 is plus 2. And the same deal happens, I'll have a modulus component. And part C, negative 5, 6 is over here. So I need to sub it into this to see whether it appears on that line. Sub it into minus 3x minus 2 to see whether it appears on this line. Or sub it into minus 3x plus 10 to see whether it fits on that line to be able to answer that question. And I'll let